Welcome to sixth grade math. Here are solutions to prior homework questions. List the first 10 multiples of each number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for 2, we have 4, 6, 8, 10, 12, 14, 16, 18, 20. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, or 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70, 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Does this look familiar? It is the multiplication table. These are actually the first positive multiples of each number. So 0 is a multiple of all numbers. And negative numbers are also multiples of numbers. When listing multiples, we listed natural numbers. Natural numbers are positive whole numbers, 1, 2, 3, etc. Mini-Lab, step 1, draw a number line from 0 to 15. And step 2, find the products of 2 in each of the numbers 1, 2, 3, 4, 5, 6, and 7. So 2 times, and then we're going to place a red tile above each of the products on the number line. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. And 2 times 7 is 14. Step 3. Find the products of 3 in each of the numbers 1, 2, 3, 4, and 5. So we'll place a blue tile above each of the products on a number line. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Which of the products of 2 are also products of 3? You look up at the number line, 6 and 12. Find the least number that is a product of both 2 and 3. So the least number, or the lowest number, is 6. It's a product of 2 and 3. So multiple, the product of a number in any whole number, 0, 1, 2, 3, 4. Common multiples, multiples that are shared by 2 or more numbers. An example, identify common multiples. Identify the first 3 common multiples of 4 and 8. So we'll list non-zero multiples of each number. Multiples of 4 are 4, 8, 12, 16, 20, 24. And multiples of 8 are 8, 16, 24, 32, 40, 48. So 8 is common between 4 and 8. 16 is common before 4 and 8. and 24 is common between 4 and 8. Notice that the lowest common multiple is 8, and there cannot be a common multiple lower than 8 because 8 is larger than 4. Notice that 8, 16, and 24 are multiples common to both 4 and 8. And so the first three common multiples of 4 and 8 are 8, 16, and 24. What is the least common multiple? 8. It's the lowest number, right? That's common multiple of both 4 and 8. The lowest number that is a common multiple to 4 and 8 is 8. Check your progress. We're going to identify the three common multiples of each set of numbers. So 2 and 6, multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, and multiples of 6 are 6, 12, 18, 24, 30. And the first common multiple of 2 and 6 is 6. The next one is 12, and the next one is 18. So the first three common multiples of 2 and 6 are 6, 12, and 18. What is the lowest number that is a common multiple to 2 and 6? Well, if we look at that, it's 6. So let's look for the least common multiple of 4, 5, and 10. And the first thing we'll do is we're going to identify the first three common multiples of all three of those numbers. So multiples of 4, 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40, 44, 48, 52, 56, 60, and multiples of 5, we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and then multiples of 10, 10, 20, 30, 40, 50, 60. And if we look, our first common multiple of 4, 5, and 10 is 20. Our second common multiple of 4, 5, and 10 is 40. And our third common multiple of 4, 5, and 10 is 60. So the first three common multiples of 4, 5, and 10 are 20, 40, and 60. And then we have to find out what is the lowest number that is a common multiple of 4, 5, and 10. Hopefully you see that's 20. Scaffolding questions. So we have numbers here. We have 3, 6, blank, 12, 15, blank, 21, 24, blank. Look at the pattern. What are the missing numbers? So 3, 6, 9, 12, 15, 18, 21, 24, 27. So 9, 18, 27 are our missing numbers. And how do you know? So you look for patterns, and we know that those are multiples of 3. Do you see a pattern in the missing numbers 9, 18, and 27? Those are multiples of 9. Least common multiple. The least number that is multiple of 2 or more whole numbers. The least common multiple is the least number that is multiple of 2 or more whole numbers. In example 1, the least common multiple of 4 and 8 is 8. In addition to listing the multiples, you can also use the prime factors to find the least common multiples. So find the least common multiple. Find the least common multiple of 15 and 40. So let's write the prime factorization of each number. So 15, we have 3 times 5. And then for 40, we have 2 times 20, 2 times 10, 2 times 5. So our multiples of 15 are 3 and 5. And our multiples of 40 are 2 times 2 times 2 times 5. So we have to identify all common prime factors. So in this case, there's only one, which is 5. So find the product of the prime factorization. and use the common prime factors once. Only use 5 once in this example, and use all the remaining prime factors. So the least common multiple, 2 times 2 times 2 times 3 times 5 equals 120. We don't want to use 5 twice. Check your progress. Find the LCM, or least common multiple, of each set of numbers. 4 and 7. So method 1 will list the multiples. Multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. And multiples of 7 are 7, 14, 21, 28, and 35. And if we look for the lowest common multiple, it's 28. Now let's use prime factorization. 4, we have 2 times 2, and 7 is prime. So the prime factorization of 7 is 7. And it's not 1 and 7 because 1 is not prime. So our LCM, if we use each one once, is 2 times 2 times 7. So our least common multiple is 28. Let's look at 3, 5, and 7. So we're adding a third number. And we're going to list the multiples. So the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45. And multiples of 7 are 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. And we have listed quite a few multiples of each number and still haven't found the LCM. So that's why we would want to use prime factorization instead, because we have quite a few numbers listed for each one. So that could get very time consuming. So let's look at prime factorization. So the prime factorization of 3 is 3 because 3 is a prime number. And 5 is a prime number. And 7 is a prime number. So our least common multiple is going to be 3 times 5 times 7, which is going to be 105. So we would have had to extend those list of multiples out to 105 in order to find the least common multiple of those three numbers, 3, 5, and 7. Real world example. Fruit baskets. Heritage Middle School is making fruit baskets for the community food bank. Apples are sold in bags of 10. Oranges are sold in bags of 7. And there are 6 bananas in each bunch. How many of each should they buy so they have an equal amount of each type of fruit in each basket? So we're trying to find the least common multiple, and we're going to do that using prime factors. So apples, there's 10, and the prime factors of 10 are 2 times 5. And there are 7 oranges, and 7's prime, so we don't have to go any further than that. And then there's 6 bananas, and the prime factors of 6 are 2 times 3. So we find the common prime factors, and we're only going to use that number once. Since 2 is common, we're going to use it only once. And they will have the same amount of each item when they buy 2 times 5 times 7 times 3, or 210 pieces of each kind of fruit. So if you want to have the same number of fruit, you have to buy 210 of each. Check your progress. A radio station is having a promotion in which every 12th caller receives a free CD, and every 20th caller receives free movie passes. Which caller will be the first one to receive both prizes? So that means there'll be a number caller that will receive both the CD and the free movie passes. So we're going to use least common multiple to find out which caller is the lucky one that gets both prizes. So the prime factors of 12 are 2 times 2 times 3, because we know 3 times 4 or 4 times 3 is 12. And then the prime factors of 4 is 2 times 2. So, and then movies, we get 20, right? 20th caller. So we know 4 times 5 is 20, but 4 isn't prime. So we have 2 times 2 times 5, and that's the prime factorization of 20. So this is different than the previous examples where we have the 2's are being used, there's 2 sets of 2's, right? So since 2 times 2 are common in prime factors, we will use it only once. So we're going to use 2 twice because there's 2 sets of 2's, and then the 3 and the 5. So the least common multiple is 2 times 2 times 3 times 5, which is 60. 2 times 2 is 4, times 3 is 12, times 5 is 60. The 60th caller would receive both the CD and the movie pass. Additional examples. Identify the first 3 common multiples of 3 and 9. So multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And multiples of 9, 9, 18, 27. I conveniently stopped because I knew those would be common multiples. And the reason I knew that is I know any multiple of 9 is also a multiple of 3 because 9 is a multiple of 3. So we have 9, 18, 27 as common multiples. And now we'll find the least common multiple of 8 and 18. So in order to do that, we'll find the prime factors of 8. Prime factors of 8 are 2 times 2 times 2. And you will come to know that the prime factors of 8 are 2 cubed. And the prime factors of 18 is 2 times 3 times 3, which can also be written as 6 times 3 or 2 times 9. But 6 isn't prime and 9 isn't prime, so we have to break out whichever way you factor that into 2 times 9 would be 2 times 3 times 3. And then we're going to do the least common multiple of 2 times 2 times 2 times 3. And the reason that is because we're basically not going to use the prime factor 18 on its own of 2 because that's going to pair up with the first prime factor of 8. So that makes it so there's only 3 sets of 2's or 3 2's. And notice that I highlighted the numbers we're using. So that equals 72. And it's not that we're ignoring that first 2, it's just that we've matched that with the first 2 of 8, and we're going to use that set once. Money, Liam, Eva, and Brady each have the same amount of money. Liam has only nickels, Eva has only dimes, and Brady has only quarters. What is the least amount of money each of them could have? So Liam has nickels, so he has 5 cents, and 5 is prime. Ava has 10 cents, and the prime factors of 10 are 2 and 5. And Brady has 25 cents, and the prime factors of 25 are 5 and 5. So our least common multiple is 2 times 5 times 5. And the reason why we have 2 5's is because each of the numbers has 5 as a prime factor. So that's going to become 1 5. And then notice there's a second 5 for 25. And then there's a 2 for 10. So that's how we get those 3 numbers that we're going to use to find our least common multiple. And that equals 50. So there's your homework for tonight. Head on over to Google Classroom to submit it. I hope you have a great day, and I'll see you in class.